Hello and welcome to helpyourmath.com. In this video, we are going to look at graphing logarithmic functions that have vertical and horizontal shifts. Before we get started with graphing, let's just review some key characteristics of the graphs of logarithmic functions. First, a parent function has a critical point at 1, 0. The transformed functions that we're going to see today will have a critical point at h plus 1, k. Logarithmic functions have a vertical asymptote. The parent function would be at x equals 0. Our transformed function will be at x is equal to h. So we're going to see a vertical asymptote at x equals h. And we want to make sure that we create a table of values where we pick x values that are powers of the base because the argument is the x value. So that's what's really important here. I like to try to relate this back to exponentials as much as I can. So hopefully we can do this nice and clearly and it makes sense even if these graphs are tough, because they really are tough. So give yourself time to kind of absorb this material as we go. We want to create a table of values and sketch the graph of the function f of x equals log base 3 of x minus 1 plus 2. In this case, what we know is that h is equal to 1 and k is equal to 2. Remember, h is always the opposite of what we see, so h is 1, and k is what we see, k is 2. From this, we know that the vertical asymptote, which is x equals h, we will have x equals 1. And the critical point, to find the critical point for our transformed function, that's located at h plus 1, k. So our critical point is going to be at 2, because 1 plus 1 is 2, 2, because k is equal to 2. Okay, so we have two pieces of information about this graph, but we need a little bit more to get a more accurate graph. The next thing we want to focus on is the base. The base is 3. So what we want to do is we want to create arguments. We want these things here, these x minus 1s, to be powers of 3. We want these to be powers of 3 of that base. So let's start with the powers of 3. So here's our exponents, and here's our powers of 3, the answers. And we would have, so remember what we want to focus on is we like negative 2, negative 1, 0, 1, and 2. So 3 to the negative 2, 3 to the negative 1, 3 to the 0, 3 to the 1, and 3 squared. 3 to the negative 2, that would be 1 over 3 squared. That would be 1/9. 3 to the negative 1, that would be the reciprocal of 3, 1/3. 3 to the 0 is 1, 3 to the 1 is 3, 3 squared is 9. Okay, those are the powers. That's what we want the argument to be. So what would we have to plug in for x to make sure that we end up with an argument of 1/9? So to set up our table, x and f of x, we want to plug in x values that will make sure the argument is a power of 3. So if we want the first one to equal 1/9, then what we're saying is we want x minus 1 to equal 1/9, which means what do we need to plug in for x? Well, if we add 1 to both sides, that means we need to plug in x equals 1 and 1/9. So we have 1 and 1/9, right? So hopefully this makes sense, because if I plug in 1 and 1/9, I have log base 3 of 1 and 1/9 minus 1 plus 2. Well, 1 and 1/9 minus 1 is 1/9. So then I have log base 3 of 1/9. That's exactly what I want to see, because I know I can compute this. What this says, this expression says 3 to what power equals 1/9? That would be 3 to the negative 2. So this thing becomes negative 2. Then we have negative 2 plus 2, which is 0. Okay, so we have our first point. What about our second point? So the second point, we would like the argument to equal 1/3. So x minus 1, the argument, we want to equal 1/3. We would add 1 to both sides. We would get x equals 1 and 1/3. So the next x value to plug in is 1 and 1/3. And what does that do for us? So now we have log base 3 of 1 and 1/3 minus 1 plus 2. Well, 1 and 1/3 minus 1 is 1/3. Log base 3 of 1/3. What this is asking is 3 raised to what power gives me 1/3? That would be 3 to the negative 1. So this is negative 1. This whole thing becomes negative 1 plus 2 is equal to 1. The next one should be our critical point. So we should find this 2, 2 again, just to double check, because I like knowing I have the right work. What we're asking for this one is x minus 1 is equal to 1, right? The next x value we're looking for, or the next power we're looking for, excuse me, is 1. So x minus 1 equals 1. That would be 2. And then if I plug in 2 into this, we would have log base 3. Since I'm running out of space, we're going to do the subtraction in our head. 2 minus 1 is 1, plus 2, because that's what the function says. Well, log base 3 of 1, so 3 raised to what power is 1? That would be the 0 power, and 0 plus 2 is 2. So there's that critical point. That's exactly what we wanted in the middle. We know we're doing something right. What do we want the next argument to be? We want the next argument to be 3. Well, I need x minus 1 to equal 3, and that means that I would need to plug in what for x? X would need to equal 4. If I plug in 4 for x, then what I have, again, I'm running out of space, I apologize for this. We have log base 3 of 4 minus 1 is 3 plus 2. This says 3 raised to what power gives me a result of 3? That would be 3 to the 1, and 1 plus 2 is 3. Last but not least, I would really like the argument to be, our last one is 9. I want it to be 9. So that's saying x minus 1 is equal to 9. What's going to give me an argument of 9? If I plug in 10, because 10 minus 1 is 9. So now what we have is we're going to have log base 3 of 10 minus 1, 9, and then plus 2 from the function. This here says 3 raised to what power is 9? That would be 2. And 2 plus 2 is equal to 4. Okay, so that was a lot of work. I hope that makes sense what I did, how we kind of have to think about the powers and force the arguments to equal those powers. So we just set up little algebraic equations to organize that. Now we're ready to graph. We're going to start with the vertical asymptote at 1. And we can start with the critical point, or you can just go down the table of values. Either way, it doesn't matter. So we have 2, 2. 1 and 1/9. So 1 and 1/9 is really close to 1. 1 and 1/9, 0. We have a little intercept there. Cute. 1 and 1/3, 1. Also really close to that vertical asymptote. 2, 2 I already graphed. 4, 3. So here we're going to see this graph start to flatten out. And 10, 4 is up here. So it starts out really sharply increasing, and then it kind of steadies out the bigger and bigger that x gets. Just to compare with the actual graph, since I did miss some of my target points, you can see my points are dead on that graph. Look at that. Perfect. If only I could actually graph it. That would be the graph of log base 3 of x minus 1 plus 2. Let's look at one more example now. We want to create a table of values and sketch the graph of the function f of x equals log base 1/2 of x plus 3 minus 5. So the 3 things we want to start out with. 1, identify h and k. So in this case, h is going to equal -3, because it's always opposite inside the parentheses, and k is going to equal -5, same when it's not inside parentheses. Now what's the vertical asymptote? The vertical asymptote is going to be located, it's the equation x equals -3, it's x equals h, x equals -3. And let's identify our critical point. So the critical point is going to be h plus 1, -3 plus 1 is -2, comma, k, which is -5. Okay, so we have that out of the way. Now comes all of the work. We are looking at base 1/2. Base 1/2 is going to be have the same powers as base 2. So we can kind of focus on the base 2, but except it's, it's base 1/2 when we come up with these exponents and powers. We really don't have to do that. No, we don't have to worry about that. Okay. So the next thing we want to do is we want to set up the exponents and powers for our base, which is 1/2. So in this case, we have a base of 1/2. I'm going to set up my exponents and my powers, the actual powers. The powers are going to be our target arguments. So our exponents are going to be, we're going to look at 1/2, our base to the -2, our base to the -1. I'm definitely going to run out of space here. Our base to the 0, our base to the 1, and can I squeeze it in? Our base squared. So 1/2 to the -2, that's the reciprocal. So that's going to flip that upside down. That's 2. Oh, and 2 squared is 4. Ooh, that's nice. 1/2 to the -1, the reciprocal of 1/2 is 2. 1/2 to the 0, this should be our critical point. That's 1. 1/2 to the 1 is 1/2. And 1/2 squared is going to be 1/4. So these are our target arguments. This is what we want our arguments to be, because these are the ones that we know we can evaluate, because that's going to be what the exponents are. Now we just have to figure out, how can I get those to be the argument? What would I need to plug in for x to force the argument to equal 4? That's what we're going to do right now. So this is kind of like the bulk of the work happens right now. Are you ready? You can do this. I know you can. Here we go. We want the first argument to equal 4. So we're going to go up here. We're going to say, okay, x plus 3, we would like that to equal 4. Oh, x needs to equal 1, right? We're going to subtract 3 from both sides. So we're going to plug in 1. Okay. If we plug in 1 for x, now we have log base 3 of 1 plus 3, log base 3, log base a half. I'm stuck in the last problem. Of 1 plus 3, 1 plus 3 is 4. So this is saying 1/2 to what power gives me 4? 1/2 to what power gives me 4? -2. So we have -2, but then it's -2 minus 5, because that's part of the function. -2 minus 5 is -7. Okay, so we have our second ordered pair, because the first one's the critical point. Next, we would like the argument to equal 2. So our argument right now is x plus 3. What would we need to set x equal in order to guarantee that the argument is 2? Well, we would subtract 3 from both sides, and we end up with x equals -1. So now let's evaluate. Let's plug in -1. This is going to give me log base a half. If I plug in -1, -1 plus 3 is 2. And then minus 5, because that's part of the function. So this is saying 1/2 raised to what power gives me 2? 1/2 raised to the -1. So this is -1. -1 minus 5 is -6. So our next ordered pair is -1, -6. Next should be our critical point. So let's verify that we agree with the critical point that we already found. Next, we would like the argument to equal 1. So we're going to say, okay, well then x plus 3 equals 1 when x equals -2. So we have -2. And now we would have log base a half of -2 plus 3 is 1 minus 5. Log base, so 1/2 raised to what power gives me 1? That would be 1/2 to the 0, and 0 minus 5 is -5. I do agree with myself. Yay! Okay, more than halfway there. Let's see what we have next. Next, we would like the argument to equal 1/2. We would like the argument to equal 1/2. So x plus 3, we would like, ideally, to equal 1/2. We subtract 3 from both sides. 1/2 minus 3, this one's a little bit tricky. It's -2.5. If you want to set up common denominators, you can. That would be 1/2 minus 6/2. That would be -5/2, -2 1/2. Okay, so if we plug in -2 1/2, let's see what happens. We have log base a half. And if I plug in -2 1/2, -2 1/2 plus 3, that equals 1/2. And we want to subtract 5. So 1/2 raised to the first power gives me 1/2. And 1 minus 5 is -4. We might start to see a pattern with our f of x's. We might predict what we expect next for our f of x. What do you think? If you said -3, let's find out if you're right. If you said something else, let's find out if you're right. The last argument we're looking for is 1/4. So we want x plus 3 to equal 1/4. If I subtract 3 from both sides, I would have 1/4 minus 3, which would be -2 3/4. So that can be a little bit tricky. If you want to set up a common denominator, -3 would be -12/4, right? 12 divided by 4 is 3. 1 minus 12 is -11. And -11/4 would be -2 3/4. So we get -2 3/4. If I plug that into the function, we have log base 1/2 of, that would be, what did we set that up to be? 1/4 minus 5. Well, 1/4 is 1/2 squared, and 2 minus 5 gives us, hey, there it is, -3. Okay, so now we have the 5 points that are going to really, really help us with this graph. Let's start by graphing the vertical asymptote at -3. And the critical point at -2, -5. And what else do we have? We have 1, -7, 1, -7. And we have -1, -6. -2.5, -4, it's like right here, and -2 3/4, so that's getting closer and closer to that vertical asymptote, -3. So you can see it's sharply coming down from that vertical asymptote. It's going down, 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 and then it kind of levels out. It's never going to totally level out, but it kind of, loses its momentum here the bigger that x gets. So this would be the graph of log base 1/2 of x plus 3 minus 5. Since the base was in between 0 and 1, we're expecting that sharp decrease and then kind of leveling out the bigger and bigger that x gets. These have been examples of vertical and horizontal shifts of logarithmic functions. Thank you for stopping by.